Hello, welcome to Slow Mo's YouTube channel. What we're going to be going over today is catastrophic events. We're not going to really have time to do this in class. So what I'm going to do here is I'm going to just kind of run through this really quickly. Floods. You'll notice that on the right over here, I'm going to have a description and an impact, and that's going to directly line up with the notes that you are going to be doing on your own. We all know what floods are, right? Floods are when we have too much water. Sometimes we will have a flood because it's raining in that same area. Other times it could rain somewhere else and the water moves towards us. For example, a few years ago, we had some really bad flooding, down under the bridge and those neighborhoods and stuff, and it hadn't rained a drop in Eagle Pass. And so what had happened there was it was raining in Del Rio and Sonora and that whole area, and Lake Amistad was getting really, really full, and they actually had to release a lot of water at the dam, and that water eventually made its way down to us. So we didn't get a single raindrop, but a bunch of houses got flooded downtown along the river, and nobody's allowed to live there anymore. The government actually bought all those properties and made those people move out, so there wasn't any more danger of flooding anymore. Hurricanes are going to be giant storms. There's a hurricane season. It's usually at the beginning of the school year, September-ish. In other words, towards the end of the summer, beginning of fall, that we have hurricanes, and those are going to be powered by warm water. So they mostly start off the coast of Africa and they move towards the United States. So we are very susceptible to hurricanes because Texas is on the Gulf of Mexico. Sometimes they hit Florida. One of the most recent ones was Hurricane Harvey. And over Earth Week, we were talking a little bit about how we're going to start having more of these extreme weather events. And hurricanes they're going to be a really, really big deal in the future because these are probably going to be happening more often, and they're also going to be a lot worse. I included a couple of pictures here of Katrina, which hit Louisiana and caused a lot of flooding and things. And you'll see on the bottom right hand corner over here that I've got let me turn on the laser pointer. I've got a map of the path of Katrina, and basically you'll notice that here in this red area, it's crossing over warmer water in the Gulf of Mexico, and this is actually where it got a lot of its power. When it hit Florida and the Bahamas here, it actually wasn't a category 5 like it was when it hit Louisiana. And so it actually got more powerful because of this warm water. So that's something that you should remember. In 8th grade, you'll talk a little bit more about hurricanes. Earthquakes, I'm not going to go over this too much because we spent a lot of time on this. We measure earthquakes by the shaking that happens, and so it causes a lot of damage. Another bad thing that happens with earthquakes is it'll cause fires and things like that. Bridges will collapse and houses will collapse. So it's really not the actual earthquake that kills people, it's the stuff that falls on top of them. So if you were in the middle of a field and an earthquake hit, you would be totally fine. You might get knocked over or something, but you definitely wouldn't get super hurt. What's bad is our infrastructure that collapses because of earthquakes. So here's how we measure earthquakes, the different magnitudes of different earthquakes. And so you'll see the magnitude on the left-hand side, and then you'll see earthquake effects, kind of, what is it going to be like, and then how many of these we have each year. So if you notice down at the bottom, the 8 or greater earthquakes are going to be totally destructive, but we only have one every 5 to 10 years or so. Tsunamis are going to be caused by earthquakes. These basically happen in the ocean. There's a shift in the plates right here. Remember, transform boundaries, they're sliding. And so we have this uplift, and it creates this giant wave. that makes it onshore and can knock down buildings and cause major flooding. And it happens within minutes. Usually there isn't a warning. They've started developing a better warning system. There's these buoys that they put out into the ocean, and those can detect when there's going to be a tsunami, or when there has been an earthquake that is possible, to turn into a tsunami. So we're getting a little bit better about detecting those. Here I wanted to show you a picture before and after a tsunami. So this is a before picture, and this is an after picture. You'll notice that there's a tremendous amount of flooding. Eventually this water will recede, but nothing is left standing. Basically everything gets knocked down and it's total destruction when we have a tsunami. A meteor, we'll talk a little bit more about this when we do space stuff. But basically space debris is going to enter Earth's atmosphere. We can have really large meteors, like the ones that killed off the one that killed off the dinosaurs. It was really one of the factors that caused the demise of the dinosaurs. Or we can have small ones. Whenever you see a shooting star, that's a teeny tiny meteor, and I'll show you some of those in class that my aunt actually found on her ranch. This is a place in Arizona. It's called Meteor Crater, and you can actually go and stand at the edge of the meteor crater. They've used it in movies and stuff. And if you look over here on the right hand side of the picture, you can see the road that goes to the parking lot right here and the visitor center, and they have a boardwalk where you can go and walk out there to the edge. They don't let you go into the crater, but scientists do go in there to excavate the meteor. Blizzards and snowstorms, we're going to have very high winds and snow and low visibility, meaning it's really, really hard to see. You should definitely not be driving during these. Sometimes the power gets cut off, which is really bad because then people get really cold in their homes, and it can get bad enough to where people can actually die. Drought is what we're going through, right? A period of abnormally low rainfall, and we'll lose plant life and animal life. Tornadoes, destructive vortex of violent wind. So you'll talk a little bit more about weather in 8th grade, like I said. Tornadoes are created when a cold air mass and a warm air mass meet, and it causes this vortex, this twisting or this turning that can actually suck up stuff and throw it and basically move it to different places. The crazy thing about tornadoes is it's not like earthquakes where they have this definitive way of measuring them. You have what's called the F scale or Fujita scale, and they measure how much damage there is. So in other words, if you have a giant, like the biggest tornado ever go through an empty field, it's going to be like a 1 on the scale. Even though it was a huge tornado, the hugest tornado that ever existed, it went through an empty field, so not very much was affected. Or you could have a small one that lasted for a really long time and it destroyed a lot of things, a lot of houses and buildings and stuff. And so that's going to actually be a worse tornado. That's going to be like an F5 or an F6. And I think they might even start going to 7s now because some of them are really bad. Again, extreme weather events. Volcanoes, we're actually going to watch a video about this on Monday. And so we all know about volcanoes, right? We've talked about this a lot when we did plate tectonics. So the video that we're going to watch on Monday is about supervolcanoes, and I wanted to show you this map of Yellowstone, which I'm going to get to go to over the summer. And there's a lot of people ask, like, oh, is Yellowstone going to erupt? Is it going to kill all of us and stuff? It's actually done it before. And so you'll see here the Lava Creek eruption, which was 630,000 years ago, and then the Huckleberry Ridge eruption, which was 2 million years ago. And if you notice, this is the older one, right? 2 million years ago, and it actually reached Eagle Pass, the ash and stuff like that, compared to Mount St. Helens, which is teeny tiny. If you look over here at this graph, this bar graph that they have, it shows you the volume of the eruption. Mount St. Helens is barely a little line, and then look at the bar graph of the Lava Creek tuff, and then the Huckleberry Ridge tuff. So this bottom one is the one that actually, if it were to erupt that badly again, would actually reach down to Eagle Pass. Wildfires, can be caused by natural things like lightning, or they can be caused by humans. Campfires that get out of hand, or cigarette butts that people throw out of their car. One thing that makes wildfires worse is suppression. Forests are supposed to catch fire every so often. It's part of the natural cycle of a forest. And that gets rid of a lot of the dead stuff that falls off trees every season. But what's happening now is that we are suppressing those fires. In other words, we don't want those fires to happen because, houses are nearby and things like that. So they're not allowed to burn naturally in the cycle like they're supposed to. And all this stuff builds up at the bottom of the forest from dead leaves and things like that. And then especially if we have drought, which is what happened in California recently. There was a really bad drought happening, and so everything was very dry and crispy. And once it caught fire, it went crazy because it hadn't burned in a long time, and there was a lot of fuel for the fire. So it's really important to let forests burn every so often. It's a natural thing. It might seem really sad and everything, which it is, but it's actually a natural part of the wildfire. In fact, some species of plants need fire in order to reproduce. For example, the redwood forests in Northern California, the naturalists there noticed that there weren't any baby redwood trees, and redwood trees are the ones with the huge trunk. The bark looks red, and they're really, really tall. And they were noticing that there wasn't any next generation of redwood trees to take over afterwards. And if something were to happen to the population of trees, like if there was a disease or something like that, there was no new generation. And they ended up figuring out it was because the actual pine cones needed fire in order to pop open and spread their seed. And so what they started doing was prescribed burns. Prescribed burns is when you set out, you set apart a piece of land, and you do basically like a perimeter around it where the fire can't get out. Like you clear some of the brush so that it won't cross over outside of your perimeter, and you set it on fire, and you control it, and everybody's watching it, and there's crews ready with water to put it out. And then you just do this to different sections of the forest, and it's allowed to go through that cycle, that natural cycle that it's supposed to. And when they did this, the next year they had all these baby trees that were starting to pop up. So fire is not necessarily a bad thing. An avalanche is a slide of a large snow coming down a mountain. This can happen because of vibrations and things like that, or the snow's not stable. And so basically it's kind of like a mudslide, but it's all snow that's coming down the mountainside due to gravity. An epidemic is when we have disease, a massive outbreak of disease. This is a picture from the Black Plague that happened in Europe, and 200 million people were killed. We could also talk about smallpox or AIDS. There's like the swine flu and things like that have happened. So an epidemic is basically when we have a lot of death because of a disease or bacteria or virus. Famine is a widespread lack of food. I should mention that these aren't in your notes, but I did want to mention them really quick. So this is when we've got, because of drought, or sometimes social factors like war, cause people to not have access to food or water. A hailstorm, we get these here, right? We can have up to baseball size hail or pea size hail, down to pea size hail. So this is gonna happen with thunderstorms. We usually get these in the summertime. A heat wave is when we have really, really high temperatures for a long period of time, something that's unusual. Ice storms can be terrible because they'll take out power. If you look at this picture that I have over here on top, basically it could the rain falls and it freezes as it hits, and it creates icicles, and these get really heavy over time, and it'll totally knock down power lines. And then people don't have heat, and people can die. Landslides and mudslides, we talked about this with weathering. We could also have subsidence like a sinkhole. But basically, because the ground is unstable, maybe there aren't enough plants, or there was deforestation or something. The basically the land just comes down, right? The soil gives way, and it could cover whole neighborhoods, like the picture on the right over here. Or we could have an underground cave, which is what's happening here on the left, I believe, where it actually caves in, and basically the ceiling of the cave gives way, and it goes into a hole. Oh, here's another picture of that. A solar flare is going to be a sudden release of energy or radiation from the sun, and it could basically take out all our phones and communication and things like that. We've had solar flares in the past, and it'll interrupt cellular service and communication devices.